Percentages, appreciation and depreciation. Appreciation is when items go up in value. Types of items that normally appreciate, well, houses normally in a normal market go up in value. Fine art normally goes up in value, and antiques can go up in value. Antique cars, antique furniture, antique jewellery, etc. Now the opposite of appreciation is depreciation, and this is when items go down in value. And items that normally depreciate, for example, are normal cars, not antique cars, and computers. Computers normally depreciate in value quite quickly. Now appreciation and depreciation are worked out in a similar way to compound interest. We covered a formula for the calculation of compound interest in our last topic on simple and compound interest. And the calculation for appreciation and depreciation is just about the same with one minor difference. So let's have a look at that. So our formula is final value is equal to the initial value times our multiplier, which is 100 plus or minus r over 100 raised to the power n, where r is our rate of appreciation or depreciation, and n is the number of years that we're looking to calculate our value for. So it's our final value is equal to our initial value times our multiplier raised to the power n. Now, appreciation, we add our rate and our multiplier should be greater than 1. And for depreciation, we minus our rate and our multiplier should be less than 1. So if you look at our multiplier, we've got 100 plus or minus r over 100 raised to the power n. And what we're saying here is if it's an appreciation calculation, it's 100 plus r over 100 raised to the power n, and if it's a depreciation calculation, it's 100 minus r over 100 raised to the power n. So let's take a look at an example. Jim originally bought his car for £9,000. It depreciates in value by 10% each year. What will the car be worth after 3 years? So the key word here is depreciates. So we're going to minus our rate as we need our multiplier to be less than 1. The final value is going to be less than the initial value. Okay, our final value is equal to our initial value, so that's £9,000, times our multiplier, which is 100 minus the rate, minus 10 over 100, raised to the power 3, because it's the number of years, so that's 3 years. So in this case, our multiplier is less than 1, so we have 9,000 times 0.9 raised to the power 3. And putting this into our calculator, we get the final value as £6,561. So after 3 years, Jim's car will only be worth £6,561. Okay, so that's our formula for appreciation and depreciation. Final value equals initial value times 100 plus or minus the rate over 100, all raised to the power n. Let's take a look at a few more examples of this in action. In our next example, Ellen buys an oil painting for £50,000. Ellen is obviously quite wealthy. Its value is expected to appreciate by 7% a year. What will the painting be worth after 5 years? And how much did it appreciate by during this time? Okay, let's use our formula. Final value equals initial value, that's 50,000, times our multiplier. And as this is an appreciation question, we will be adding our rate. Our multiplier needs to be greater than 1. So that's 100 plus 7 over 100, all raised to the power 5, because 5 is the number of years we're calculating this appreciation for. This gives us 50,000 times 1.07 for our multiplier, raised to the power 5. Now that's good. Our multiplier for appreciation has to be greater than 1. Now plugging these figures into our calculator, we get £70,127 and 59 pence as our final value of the oil painting after 5 years, and then we need to calculate the amount that the oil painting appreciated during this time. So the change is equal to the final value minus the initial value, so that's 70,127.59 minus 50,000, so that gives us £20,127 and 59 pence. That's been an excellent investment for Ellen, as the painting has gone up in value considerably over that 5-year period. So keep in mind this was an appreciation question. Our multiplier will be greater than 1 as we will be adding the rate. Okay, our next example, or final example, is a little bit different. The population of a rural village is 1600. It is estimated that it will decrease, the population will decrease at a rate of 15% a year as people move away to large towns. So it will decrease, so this is a depreciation question. After how many years will the population be less than 1,000? Okay, so we need to work out n, the number of years it will take for this population to be less than 1,000. Now, there are a number of ways to solve this. We're going to use a very simple way to solve this question. So what we want to work out is our multiplier. Our multiplier is 100 minus 15, because it's a depreciation question, over 100 raised to the power n. So this is 0.85 raised to the power n. So how we're going to solve this one is we're going to do this by trial and error. So let's try 2 years. What happens if we use n as 2 years? Well, final value equals the initial value, 1600, times our multiplier, 0.85 raised to the power 2, and that gives us a population of 1,156. So the population is not less than 1,000 yet. So let's nudge it up to 3 years. Let's try n is equal to 3 years. So that's 1600 times 0.85 raised to the power 3, and that gives us approximately 983 people, and the population is now less than 1,000. So the population will be less than 1,000 after 3 years. So this question is slightly different. You're not just plugging in the values, you're doing a little bit of trial and error to work out the number of years. It will take the rural villages population to decrease to less than 1,000. Now, appreciation and depreciation questions are quite common in exams, so it's important you understand how to do these. It's fairly straightforward. Final value equals initial value times your multiplier raised to the power n, and just keep in mind for appreciation you add the rate, the multiplier must be greater than 1, and for depreciation you subtract the rate, your multiplier must be less than 1. That's it for this topic on appreciation and depreciation. It's now time for you to go off and practice.